Today we're going to look at multiplying and dividing rational expressions, and remember, a rational expression is just a fraction with polynomials, so that means all the fraction rules will still apply. So let's do a couple of examples just with basic fractions to kind of remember how things work. So with a fraction, so this first one we got 6 over 10 times 2 over 3, and the rules for multiplying fractions basically are you just multiply the top numbers and multiply the bottom numbers, and then you would simplify. So in this case, if we multiply the top, we have 6 times 2 is 12, divided by 10 times 3 would be 30, and then we could simplify that to, if we divide both of them by 6, that would simplify to 2/5. Okay, so that would have been the way you probably would have done something like that in junior high. So multiply the tops, multiply the bottoms, and simplify. But what I want to do is let's kind of look at this one again, and instead of multiplying first and simplifying, let's see what would happen if we simplify first. So if we simplify, basically what we want to do is want to see, can we divide out any common factors on the top and the bottom. So if we actually changed 6 to, that's the same thing as 3 times 2, and if we change 10 to 5 times 2, you can see now what we're basically doing is we're getting some common factors on the top and bottom. So we could cancel out a 2 on the top and bottom, and we could also cancel out a 3. So then our final answer, we just have a 2 left over on the top and a 5 left over on the bottom. So you can see we get the same answer whether we multiply first and then simplify, or if we just simplify and then cancel things out. And that's the method that we're going to actually do to solve rational expressions, because it's going to be too tough to try to multiply and FOIL things out. So what we're going to use is this second idea of try to simplify first and then do a bunch of canceling. Let's look at a dividing question the same, and to kind of remember how we divide fractions. So the trick with dividing fractions, remember, is we actually rewrite the fraction as multiplied by the reciprocal. So we don't want to divide, we want to change it to times by just flipping that second fraction. Then once you do the flip, it becomes the exact same thing. So let's look at doing that. It's kind of like we did this first question, the second way. So we want to change, let's do common factors on the top, so we could actually divide out a 4. So that would be 4 times 25 on the top, and on the bottom 33 would be the same thing as 3 times 11. So now when we multiply 11 over 4, you can see we can actually cancel out an 11 on top and bottom and a 4 on top and bottom. So our final answer is 25 over 3. Okay, so that gives you an idea of how we did it with regular fractions. So now what we'll do is let's continue this idea with rational expressions. Okay, so when we're dealing with rational expressions, the same sort of rules apply. So what we want to do is, sort of the first step in any case is factor as much as possible. So if the question needs to be factored, do that first, either by taking out a greatest common factor or by doing square root factoring. Then the second step is cancel anything on the top and bottom across any of the fractions. It doesn't matter which one it's in, as long as there's one on the top, one on the bottom. And then the last step, just like we did before, is state non-permissibles. And you got to make sure you do that for both fractions this time. So if we look at this first example, we can't do any factoring, right? It's factored as much as possible, so we're ready to cancel. So we can cancel an x on the bottom with one of the x's on the top, so that leaves us with just an x left over on top. And out of the 6 and 8, we can cancel out, just divide them both by 2 would be all we can do. So divide by 2, that gives us a 3 and a 4. So our final answer then is we have a 3 and an x left over on top, and just the 4 left over on the bottom. And that's it. So cancel whatever you can, top and bottom, and then do your non-permissibles. Remember, your non-permissibles always go back to the original. So in the original we have an x on the bottom, so that means x can't equal 0. And then we have an 8 on the bottom, which has no non-permissibles. So that's it, we're done. Okay, so let's do another one, kind of like we just looked at. So in this case, we've got 12a cubed over 8a times a squared times 4a. And the question can be written with times as a dot. We could have times as the x symbol. We could have brackets. It doesn't matter. They're all the same thing for multiplying. So whichever it's written as is totally fine. Okay, so in this case we're ready to cancel. So we've got, we can cancel a 4 on the bottom with a 4 on the top, so that would leave us with a 3. And we've got 1a on the bottom, 2 a's on the bottom, that'll cancel with the other 2 on the top. And that's as far as we can go. So our final answer should just be 3a cubed on the top and an 8 on the bottom. And that's it. And our non-permissible, we have a 0 for the first one, 8 times 0 would be 0, and for the second one, 0 as well, because it's 4a. So in both cases, we'd have just a can't be 0, and that's it. So 3a cubed over 8, and a can't equal 0 for the answer for that one. Okay, let's go through a couple more that are a bit harder. So you can see in this first case, we can't cancel anything other than the 3 and the 6, but we can do some factoring. So the first step you want to do is factor the top, so we can take out a common factor of an x. So that'll leave us with x minus 1. The 3 is done, and on the other fraction, 6 and x minus 1 are both factored already, so that's as far as we can go. So now that we factored it, you can see we can cancel the entire factor of the x minus 1, and we can also cancel a 3 out, so that would leave us with just a 2 on the top, and that's it. So our final answer should be x and a 2 on the top, so let's write it as 2x. The bottom, everything cancels, so we could write it as a 1 if we want. We could write it as 2x over 1, or we don't need to, we can just leave it as 2x. And our non-permissibles, the 3 has no non-permissible, the x minus 1 would be positive 1, so x can't equal positive 1. And that's it for that one. The second example I got here, you can see everything's already factored out, so we don't have to do any factoring. So now we're ready to cancel, so we have an x plus 3 that cancels. We have 14 will cancel with a 21 if we divide them both by 7, so that'd be the same thing as 2 over 3. And that's it. We can't cancel an x plus 2 because we have an x minus 2 on the top. So those two aren't the same, so we can't cancel those. And you can't just cancel just the x or anything like that. It has to be all or nothing. So that's all we can do for that one. So our leftover on the top would be 8x and x minus 2. And on the bottom we have the 3 and the x plus 2. So we'd write it like that, and we're done. So our non-permissibles, the first one we'd have minus 2. For the second one, the 21 doesn't do anything, and we have minus 3 for the second one. And that'll be it for that question. Okay, let's look at dividing now. So remember with dividing, when you divide fractions, what you have to do is change it to multiply. So this first one, well, let's rewrite it as 12 over x squared times x over 3. So now that we flipped it, we're ready to factor. In this case, there's nothing that needs to get factored. We're ready to cancel, so we can cancel one of the x's with one of the x's on the bottom, and cancel the 3 with the 12, and then leave it with the 4 left over. So our final answer should be 4 on the top and an x on the bottom. Okay. One other thing you got to be careful of with now with non-permissibles is we have to do the bottoms of our original fraction. So we have x squared and an x, so both of those would be 0. But because we're dividing, we also have to worry about the top of that one, because once we flipped it, remember we flipped that fraction, it becomes the bottom on the new part. So in this case, it's the 3, which doesn't have a non-permissible, so we don't have to worry about it. But we would have to worry about it if it was like a 3x or x minus 2 or something like that. So what you have to remember with dividing is your non-permissibles will be the bottoms always, but also the top of the second one, because it gets flipped and becomes the bottom. So in this case, that's all we'd have to do. The second example we got here, so same thing, let's rewrite it so that it's times. It'll be x minus 3 over x minus 1, and that'll be times x minus 1 over x plus 1 once we do the reciprocal. Now we're ready to cancel. So you can see the minus 1s would cancel, and that's it. So we have an x minus 3 on the top and an x plus 1 on the bottom, and that's as far as we can go. So our non-permissibles are, we got 1 for the bottom, negative 1 for the bottom, and then we'd also have a positive 1 for the top, but we've already got that one, so we don't have to worry about it. So that's it for those ones. Okay, let's look at another example. So this one we got 5x minus 5y over 10 divided by x squared minus y squared over 2. So it's division. So first step, let's change it to a multiplying question. So we'll multiply by the reciprocal. Now that's done, so now we have to do factoring. So on the left side we can common factor out a 5. And for the second fraction, we can square root the bottom, right? We can square root both of those. So we'd have x plus y and an x minus y. So we've got everything factored as much as possible, so now we're ready to cancel. So we have a x minus y's cancel. We can divide out a 5 out of 10, that'll give us a 2. We can cancel the 2's. And that's it. So our final answer is 1 over x plus y. So that's it for our answers. This one we got to be a little bit careful because our non-permissibles now, we've got the 10 on the bottom, that doesn't have any. We got the 2 on the top, that doesn't have any. So all we got to worry about is the x squared minus y squared, which is these two factors, x plus y and x minus y. So because we have two variables, we basically just have to do the opposite. So we'd have x can't equal negative y, right? If we bring the y to the other side, that would make a negative y. And then for the other one, we have x minus y. So if you bring the y to the other side, that would be just x can't equal positive y. So that's our two non-permissible values. So this case is kind of weird because they're not numbers, they're y's, but you still do the same thing, just the opposite. So you'd have positive y and negative y for both. And that's it. So we'll stop there. That shows you how to do multiplying and dividing. So you can see the process is kind of the same as simplifying. You need to remember if it's dividing, flip the fraction so it becomes a multiplying. Then you factor everything as much as you can, cancel as much as you can, and then do your non-permissibles. So it's pretty basically the same idea, just we're dealing with two fractions now instead of just one.